So today is day 9. I'm gonna show exactly what I did today. Basically, the first thing what I did was to implement the architecture of WaveNet, which is used mainly for signals. I mean, was designed for signals, but this is the way the architecture works. And we take the concept and apply it into words, but characters within the words. So the way we do it, it's basically we took the previous code, what we did, in which we have the names, right? And we create bigrams with the names. I mean, n-grams, because we can decide how much context do we want in order to predict the next word. And not only that, but we implemented the PyTorch version of this, which is this one. And we have to take into account very important layers. I mean, it's an abstraction. It was layer by layer abstraction, because first was implemented this from scratch, then was using the Torch modules, and then was implementing the containers of Torch, for example, a sequential container. And then what I did was, in order to implement WaveNet, we have to compute not only because in bigrams we take the context, compute the next characters. In WaveNet, we have to take into account the characters and then combine these inputs in order to create an output. And then this output, we use it as an input of another layer. So it is not like a single layer in which everything enters, then exits, and then it's added, but it's more like concatenated in this way. So we start by these bigrams, and instead of chunking, for example, using all of these as input, we divide it as pairs. I mean, we divide it as pairs, and in this way we basically compute like the different possible linear combinations that exist between pairs and the concatenations in order to create the neural network. And we derive that this is exactly equal as computing using convolutional layers, but using convolutional layers is even better because it's more efficient. But the convolutional layer is a linear mapping also, that takes the combinations as a kernel that traverses the image. But yeah, that's it. We did this. Next time we can use convolutions. And the other part that I did was this exercise in which I implemented the continuous bag of words model, which was this one, which basically computes, we want to compute the word to back, right? And the way to get embeddings is by computing, trying to predict a word within a context, and the resulting weights map into the actual embeddings of the tokens. So we take the a corpus, which is I don't know, this book, 20,000 Lieues sur le Mer from Verne, and we divide the words. We have the tokens, and map them into numbers, and define the layers in PyTorch, train the model, and get actual context. And that's it. And then with this we can use another library, which is Gensim, and try to see from a given word, grab the embedding and use the embedding to search other similar words. And I mean, this is very useful because this kind of search we do it in RAG, and that's it. And everything falls into the idea that words can be understood in a geometrical place, so they represent a vector in space, somewhere in the space, and the closer two words are together, the closer the meaning they have. And yeah, that's it.